Are you recording this today?
I forgot to yesterday, but I did the other day too. Because we have kids that are wonky.
Oh, yeah.
So, today we're going to talk about series, the idea of a series. Okay. Up till now, we've talked about sequences, which is just a pattern of numbers. Today, we're going to venture into what is called a series. They are connected together. But when we have a finite sequence, you have, as described by the adjective that is there. There's your English term of the day. When you have a finite series or sequence, you have a definite number of terms. It stops. You have a beginning and you have an end. And when you have an infinite, well, now our adjective is an infinite. So you have an infinite number of terms. It will continue on indefinitely. And the example for a finite is 1, 4, 7, 10, 13, 16. It starts at 1 and ends at 16. There's a finite number. I have 6 terms there. But if I look at the pattern of numbers 3, 7, 11, 15, comma, dot, 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 when you start seeing the dot, dot, dots, that tells you it will continue on indefinitely. You have an infinite number of terms. So if you look at what is the characteristic nomenclature-wise of finite and infinite, when you have the dot, dot, dots at the end, that's going to go into an infinite idea. When you have finite, you will stop. Well, when we talk about a series deals with a sequence. But when you talk about a series, it's the sum of terms of a sequence. You add up all your terms of the sequence. And how we symbolize that is S, capital S, subscript n. That just tells you have the sum of n number of terms. What's the sum of the first 10 terms or 8 terms or 9 terms? So if we take a look at 3, 7, 11, 15, 19, 23, 27, 31. And we want to turn this sequence into a series. Well, to turn this sequence into a series, we could take 3 plus 7 plus 11 plus 15 plus 19 plus 23 plus 27 plus 31. You take out the comma signs and you put in an addition sign. Now, if you were given this on a test, I wouldn't sit there and say, you know what, you need to know these formulas, so on and so forth. You have 8 numbers you have to add up. You can sit there and clickety-clack and do the calculator and add them up. Okay, I get that. But the problem you run into is if I ask you, what is the sum of the first 500 terms? Yes, you can do 500 terms in your calculator. But I don't have the patience for that. So let's take a look what happens with the sum of the first 8 terms. I can write that as a capital S with a subscript 8. Well, when you talk about addition, you have a property called the associative property of addition. If you have addition there, the associative property says you can mix and match the terms however you want and add them together. So I don't have to go in the order 3 plus 7 plus 11 plus 15 and so on. I can go 3 plus 23 plus 15 plus 11 plus 27 plus 30. I can go in a different order, and I should get the exact same answer. That's, once again, the associative property of addition. Well, what I'm going to look at here is I'm going to look at if we would take the first and last term and add the first and last term together, we would get 3 plus 31, which is 34. If I would take the second term and the second to last term and add them together, we would get 7 plus 27, which is 34. If we would take 11 plus 23 and add them together, we would get 34. If we would take 15 and 19 and add them together, we could get 34. So rather than adding all these numbers together, I can add 34 together 4 times. Or if I change this into a multiplication problem, we can say this is 4 times 34. To give us 136. So we can change this into a multiplication problem. And that's what happens with a sequence, arithmetic sequence. But let's take a look at the next one, and let's add one term to this. If we add one more term to this and get an odd number of terms, yes, if I wanted to, I could click-clack it through the calculator. I have 9 numbers I can add. I could do that. But just follow the same method of madness we just did up top. If we would add our first and last term together, we get 38.
Oh, catch up with this later.
If we add our second and second last term together, we get 38. If we add our third and third to the last term together, we get 38. If we add our fourth and fourth to the last term together, we get 15 plus 23. We still get 38. So we get the same method of madness up here, the same idea up here. So we would get 4 times 38, but the problem we run into, we still have this 19 in there that we didn't add in. So we'd have to add this value of 19. So that gives us a problem within our logic of what we were doing here, how we can use our associative property. But also the problem we run into is this is a lot of work to be able to start matching up and adding together. If we have 20, 30 values or 40 values or 500 values here, that's going to be a difficult thing to do. So let's take a look at one other idea. I add all these together and they add up to 38. This value here is a value of 19. Mathematically, what could we do to the 38 to come up with 19? Well, let's go the other way. What can we do to 38 to get to 19? divide by 2. We can subtract 19, or we can divide by 2. So if we would take 38 and we can divide that by 2, we get this value of 19. Well, when I add the two numbers together and divide by 2, what are we doing with our two numbers? We add the two numbers together and we divide by 2. What are we doing? Find the average. So this is the average. So if we think back to what we talked about with respect to averages, an average is a number that we can substitute in to represent the numbers that we are averaging together. It gives us that one value that would represent those two numbers. So rather than having 3 and 35, would the sum change if we had 19 and 19 there? If I would add all these terms up and take out the 3, take out the 35, and replace them with 19 and 19, would I get the same number? Yeah. Well, if I would take the average of the next two, I would get 19 again. So I would be able to replace this with 19 and replace this with 19. Well, if I divide the next set of numbers by 2, I get 19 again. So I can replace this with 19 and this with 19. Well, if I take the next set, divide by 2, I get 19 and 19. And then I have this value of 19 here. So really, what we are adding together, we can manipulate this into 19 being added together 9 times. Well, mathematically, rather than clickety-clacking our calculator, 19 plus 19 plus 19 plus 19, we can also write this as 9 times 19. And we come up with our 171. Which now allows us to be able to generate some ideas here. This value of 9 is the number of terms that we have here. This value of 19, how did we come up with the value 19? Well, I average my first and last, my second and second last, third and third last. Well, if this is an arithmetic sequence, if I average my first and last term together, that's going to be the same as the average of the second and second to the last term, the third and the third to the last term. It will be my average of all those numbers that I matched up. So really, we don't need to have all the terms there. What's important is, what is my first and what is my last? Because I can average the first and last term together. We can average our first term. I can average my first and last term together. And then multiply this by however many terms I have. So to find a series for an arithmetic series, we can average our first term and last term together and divide by the total number of terms. And now we'll calculate for an arithmetic series. What we will also need to utilize for an arithmetic. Tn is equal to T1 plus D times n minus 1. Because we need to be able to find that nth term. We need to be able to find that last term. Because if I have 500 or 101 terms, if I have 101 terms, what I'm asking for in the next one, I'm not going to go, okay, 3, 7, 11, 15, 19, 23, 27, 31, 35. That gives me 9 terms. Well, my 10th term is going to be 43 or 39. My 11th term will be 43. I'm not going to count out 101 terms. But we can find our 101th term by knowing our first term, our common difference, and the term number we're trying to find. Well, what would be term 101? Well, we have an arithmetic sequence. We have a common difference of 4. I have a first term of a value of 3. So we have our first term of a value of 3. We have a common difference of 4. We want to find the 101st term. It's always nice when I give you the 101 or 501 and 701 because I have to subtract 1 from that, which gives me a nice little 100, 200, 300, 400. So term 101 is what, Ian?
403.
403. Taking 3 plus our common difference, 101 minus 1. So we have 403. This is my last term. So this sequence or series goes 3 plus 7 plus 11 plus 15 plus, and this will continue on all the way out to 403. This is term 101. So what we now know is our first term and our last term. So when I average them together, that's going to be the average of my second and second to the last term, which would be 399 and 7. So my average here is going to be my average here, which would be my average here. So if I just find my first and last term average, if I find my first and last term average, that would be my averages for all the ones that match up. So we have 3 plus our 403. We have to take the average of that. And we have a total of 101 of those. So we can multiply by 101. This here is manipulation of mathematics. All the mathematical concepts that you have talked about throughout, we are now manipulating them to make them work for us. Yeah, there's no black magic here. There's no Tinkerbell pixie dust that's being thrown on top of this. Okay, we are just using mathematic knowledge that we have developed throughout and applying it to something that's different. And as you advance on in your math careers, if you stop at this level, that's great. But if you advance into the calculus world and beyond Calc 1, Calc 2, Calc 3, that's what that will be. All those mathematical concepts that you have touched on for years, we now start applying them to something different, and everything will be new for you. Sort of like this. You said you dealt with sequences in some of the other classes you had below this. Don't know if you dealt with series though. So we have 406 divided by 2 times 101. Jocelyn, what do you have for the series here?
Oh, as in, sorry. 20,000.
20,000 what?
503.
20,503. Good with that? Now we won't worry about the next one. So in general, we can find the sum for an arithmetic once again as how many terms times term 1 plus Tn divided by 2, the average of the first and last term. What you'll want to know and throw with that is Tn is equal to T1 plus D times n minus 1. And if you're in a recursive formula, Tn is equal to Tn minus 1 plus this common difference. So these are the three things that we've dealt with respect to arithmetics. Now, when we get into calculus, there's some other rules that we will utilize in regards to series. For like an n squared, for an n cubed, how you can find your series for n squared that's cubed. We won't worry about them right now. And we talk about geometric. Talk about geometric, we have a series here. Once again, my suggestion to you, if you're asked to find this geometric series here, and you have 5 numbers, don't sit there and try to memorize a formula and remember that. Okay, click it through the calculator. That is a fallback that you could go into. If you're sitting there on a test in this class, and for geometric, we're not going to go as big with respect to our series, just because the numbers get really big. You know, if you have 10, 11 numbers, you can always, if you wanted to, sit there, click 10, 11 numbers in there. If we would add these 5 terms together, we can go 2 plus 6 plus 18 plus 54 plus 162. And what do we come up with? My brain hurts. 26, 80, 242. My bad. We can do this and this. That gives us 20.
Yeah, it looks right.
This gives us 60. That gives us 80. 80
So?
plus 60, 162, 242. I'm not going to go into an elaborate proof of why this works. It's a little bit more involved. But if you're taking a geometric, and you talk about a geometric series, how you can find the sum of a geometric series is we can take our first term. The nice thing about geometric series, you don't have to know what the last term is. Okay? If it's a geometric series, we have our first term times 1 minus r to the nth power. So you need to know your ratio, but you don't have to know that last term. But you need to know your ratio. You take r to the n power, however many terms you're dealing with, and divide that by 1 minus your ratio. We get 242 up top. So if we would take a look at this as our formulas, we could take our first term. We have 1 minus our ratio. Our ratio here would be a value of 3 multiplied by 3. So we have 1 minus 3 to the 5th over 1 minus 3. And if you would click that through the calculator, you should come down to the exact same solution. And once again, that's just dealing with your calculator. Make sure you quantify 1 minus 3 to the 5th power, then quantify. Okay, the only thing going to the exponent of the 3's only has the exponent of 5. It's not 1 minus 3 to give us negative 2 to the 5th. It is 1 minus 3 to the 5th power multiplied by 2 and divided by negative 2. If you want to, if you get confused by the quantity, you can click in your calculator 1 minus 3 to the 5th, hit enter, hit divide by or multiply by 2, that times it by 2, and then divide by negative 2. Okay, and you should come down to the same value, 242. So if I have 3, 6, 12, 24, 48, find your common ratio here. Find the sum of 14 terms. Okay, go ahead and do the last two problems. The first one will be a geometric series. Second one will be an arithmetic at the bottom. So you have to refer back to the front again. Check your answer with somebody around you.
Yeah. You'll pass up, leave your phone here.
Once again, I know the first one, if you wanted to, you can add up 14 terms, but you can start to see, you have 14 terms, you have to keep on, that's a lot of click-clacking in the calculator. Numbers get a little bit bigger. So if I go 3 times 1 minus 2 to the 14th divided by 1 minus 2, Micah, what do you come up with? 49,149. Good with that? Okay, bottom one down here, we have an arithmetic. We have to find our 301st term first. Okay, we have to find what is that last term. We start out with 5. We want to find the sum of the first 301 terms. What's term number 301? What do we have with that? Oh, let's see here. What do we have? Corbin, what do you have? What's term 301? So we have 1,805 as the 301st term. We can average that with my first term. So we can add it to 5, divide by 2, then multiply by 301. Alex, what do you get for a solution?
272,405.
272,000?
405.
405. Good with that number? Okay, once again, if you needed to, you could add up 301 terms. But that's a lot of terms to be able to add up. All right, questions you have? Once Again, the nice thing about the geometric is you only need to know that first term. You need to know first term and ratio, and how many terms you're dealing with. Arithmetic, you need to know first and last term, how many terms you're dealing with here. All right, rest time adjourned, solutions are posted.